Hello, our overarching project slash program is called TF, which is a play on words with the individual components of our project, which are called what, why, and how. So TF is a collection of compilers that together implement a C-like high-level language. The absurdity of this project is not based at all in our language itself, but in the sheer magnitude of the gulf between the language and its compilation target. Our language targets a tiny superset of a language called BF. We're only allowed 14 operators that can manipulate a Turing tape in a super inefficient manner. So we can increment, decrement, move a pointer left and right. Here are those specific operators, if you want to pause and look at those. So to tackle the problem of compiling such a restricted language, we first made a much less restricted language, a reverse Polish notation assembly language called Y. Y allows us to use a stack and a heap, which are much more convenient ways for us to think about code rather than a Turing tape. As you can see, while the abstractions Y offers might sound very simple to implement, I assure you they were not. Integer division is equivalent to about 60 BF instructions, as you can see in our microcode there in this picture. So it's very complicated. Using our new assembly language, Y, as a foundation, we then implemented what, which is a C-like high-level language. It has pointer types, function types, primitive types like integers, booleans, characters. It has a strict type checker, strongly typed. And it has various forms of control flow, like if statements, while statements, function calls, and it also has a manual memory management. So you can use alloc and free, similar to how you would use malloc and free in C. Altogether, most of the time was spent implementing what and why, but we also had time to experiment and implement a few related toy compilers, including a self-hosting compiler in BF, which is a mirror implementation of a compiler that we wrote in C to compile the output of this, this programming language into machine code. So why did we make this? We made this because we were really impressed by the universal power of Turing machines. And we kind of wanted to explore that a little bit. It's a really interesting topic. And we learned a lot about the equivalency of Turing-complete languages, how there's always an algorithm to convert one Turing-complete language into a program in another Turing-complete language. There's always an algorithm, however complex that may be. As for anything we'd like the judges to consider, keep in mind that this is a very, very complex project, and we only have 5 minutes to discuss this in a video. There are a lot of things that we can't really go over in that amount of time, such as how we dealt with nested scopes that return values, how we dealt with frames, how we implemented a stack and a heap on a Turing tape. This is a really high level computer science problem, a really fun one. We're really satisfied with our results. So, so that's all. Thanks.